Today, we're diving into a cosmic object that is so mind-bendingly huge, so incredibly massive, that it almost feels like it shouldn't exist. We're talking about a true monster of the cosmos, a behemoth known as TON 618.
It seems like a pretty simple question, right? But the answer is where things get really wild. We know black holes are massive, but there are levels to this stuff. And then there's TON 618, which is on a level that completely shatters what we thought was possible and forces us to rethink how the universe even works.
Okay, just to try and wrap our heads around the scale here, look at this. On the left, that's our home, our entire solar system, all the way out to Neptune. And on the right, that's just the event horizon of TON 618. The point of no return. It's not just a little bigger. We're not even in the same league. It could gobble up our solar system whole more than 40 times.
And its mass? Well, that's where it gets truly staggering. 66 billion times the mass of our Sun. Let that sink in for a second. This one single object is heavier than all of the stars in our own Milky Way galaxy combined. It's a true gravitational titan.
So how in the world did we find this thing? Well, the funny part is, for a long time, we were looking right at it and had no idea what it was. It was just hiding there, in plain sight, completely misidentified.
Yeah, if we go back to 1957, it was just another dot in a catalog, listed as a faint, kind of violet-blue star. Nothing special. But then in 1970, astronomers picked up radio waves coming from it, and that was the first clue. Stars don't do that, but you know what does? Quasars. By 1976, after analyzing its light, we confirmed how ridiculously far away it was, which meant its brightness was something else entirely.
And that's exactly what TON 618 is, a quasar. So what is that? Think of it as the super bright, intensely energetic core of a galaxy. And what's powering this incredible light show? A supermassive black hole that's in the middle of a cosmic feast, surrounded by a swirling disk of superheated matter that's about to be devoured.
So the quasar is the dazzling light show, but the engine making it all happen is the real star here, the black hole itself. And as you're about to see, calling it supermassive is a massive understatement.
For a bit of perspective, let's start at home. Right at the heart of our Milky Way, we have Sagittarius A star. It clocks in at about 4 million times the mass of our Sun. Pretty hefty, right? A real beast. Okay, hold that number in your head.
Now look at this. That tiny little sliver on the left, that's our galaxy's monster black hole. And that colossal bar on the right, that's TON 618. It's at least 10,000 times more massive. The difference is it's just mind-bending.
In fact, TON 618 is so ridiculously off the charts that it helped push scientists to propose a whole new classification. These things aren't just supermassive, they're ultramassive. They are truly in a league of their own.
All right, so here's the big paradox. We all know black holes are famous for one thing. Light goes in, but it doesn't come out. So how can one of these things be powering one of the brightest objects we've ever found?
I mean, the amount of light this thing pumps out is just absurd. The quasar, powered by TON 618, shines with the light of 140 trillion suns. It's so unbelievably brilliant that we can't even see the host galaxy it lives in. It completely drowns out the light from billions of stars.
So how does this actually work? Well, the light isn't coming from inside the black hole. It's coming from the stuff falling into it. As gas and dust get yanked in by that immense gravity, they form this huge swirling traffic jam called an accretion disk. The friction in this disk is so intense that the matter heats up to millions of degrees and glows with an unimaginable brightness. That's the quasar. But the story of TON 618 isn't just about being a giant. Because it's so incredibly far away, it's also a time machine. When we look at it, we're getting a direct glimpse into the ancient past of our universe.
The light we see from TON 618 tonight started its journey 10.8 billion years ago. We're not seeing it as it is today, we're seeing it as it was when the universe was just a toddler, still figuring itself out. We're looking at a fossil made of light.
And if that wasn't wild enough, there's more. The entire quasar and its hidden galaxy are wrapped up in something called a Lyman alpha blob. It's this gigantic, glowing cloud of hydrogen gas. And what's making it glow? The intense, blistering radiation that's being blasted out by the quasar right at its center.
And when I say gigantic, I mean it. Our own Milky Way is about 100,000 light-years across. This single cloud of gas around TON 618, it's over 300,000 light-years wide. It's a structure that dwarfs our entire galaxy. So,
The size, the brightness, the age, it all leads us to one massive, glaring question. How on earth did something this huge get so big so early in the history of the universe?
And this is the real kicker for astrophysicists. Finding a monster like TON 618, already fully formed when the universe was so young, basically breaks our standard models of how black holes are supposed to grow. According to our theories, it simply shouldn't have had enough time to get that big.
So what are the leading ideas? Well, maybe it didn't grow from a small seed like we thought. One idea is it formed from the direct collapse of a truly massive cloud of primordial gas. Or maybe it was born in a really rough neighborhood of the early universe, the result of a chaotic smash-up of galaxies happening over and over again. Or maybe it just went through a super efficient feeding frenzy for a while. The honest answer is we just don't know for sure.
And that's really the question TON 618 leaves us with, isn't it? How do you grow a monster in an infant universe? It's a relic from a time we can barely imagine, and it's a powerful reminder that no matter how much we think we know, the cosmos always has bigger, deeper, and more profound mysteries just waiting for us to find them.